Hey, thank you for coming back. They love me. No, I'm just kidding. Let's go. Today we're going to find the Pythagorean Theorem. Excuse me, we're going to find distance using the Pythagorean Theorem. All right? So I'm going to show you here the basics. And what I like about this is that this is something you can actually apply in real life, right? So as you notice here, I have these two lines right here. So what I really want to find is the distance right here. From this point here, oops, what happened? Hello, pen. Oh, let me choose a different, oh, what happened? Okay. Hey, let's keep it orange. A lot of mistakes happening, but you know what? We're not Hollywood here. So we're just gonna do what we do. All right. So we're gonna put a point there and put a point here. Because what I really want to do is find the distance between those 2 points, right? So let's go ahead and connect those lines here just to show you that I'm going to find the point distance from here all the way down here. All right. Oops. There you go. All right. Here we go. So that's the distance we want to find. For that, obviously, we want to apply the Pythagorean Theorem, which is a squared plus b squared equals c squared. Now, the common question is which one is a and which one is b. The good thing for you is that it doesn't matter. So this side can be a or b and the bottom can be a or b. It doesn't matter because if you think about what's happening to a and b, they're just being added together. So remember, in addition, we can use the commutative property and move them around, so it doesn't matter which order I add in. All right. So for this example, we'll just make this a and we'll make this b, and this long side always, listen carefully, always has to be c. All right, that's our hypothenuse, and that's the distance that we're going to find anyway. So how do we find it? Well, simple. Let's just count the spaces here, which is, in this case, I notice that my x values go up by 1. So then I just count 1, 2, 3, 4, 5, 6, 7, 8. So A has a value of 8, and B, 1, 2, 3, 4, 5, 6, 7, 8. Oh, B has a value of 8 as well. Nice. All right. So all I'm going to do is I'm going to plug them in here. Okay. So they're both the same value. And I didn't expect that. Maybe I should work these problems before I actually do them, right? Now, notice I have the 2 8s, which are the distances. But don't remember, they have to be squared. So we're going to square this. We're going to square that and set it equal to c squared. All right. So simple enough. 8 squared is 64 plus 8 squared, which is another 64, is equal to c squared. So this obviously is 128. 128 equals c squared. And always, we cannot leave the variable with a square, right, to the power of 2. We must take that off, undo it. We undo it using radicals. So we're going to take the square root of each side here, this side, and this side. So this ends up being c equals, and 128 should be, actually, you know what? Since 128 is not a perfect square, I am just going to leave this as the square root of 128. You can write that as your final answer for the distance of c. Now, if you got to listen to your teacher. What are they asking for? Maybe they want you to estimate this. This would be like 11.3 something. If they want you to do it, write it as a decimal instead of approximate distance, right? You would do that. So otherwise, this would be an exact answer here of a square root of 128. And that's how you use the Pythagorean Theorem to find distance. I'm going to show you one more just to find the distance when you have C, but you don't have either A or B. All right, let's take a look. All right, and here we go. Notice I got rid of the graph because I didn't want you to think that this is only applicable when you're using a graph. It's always applicable when you're using a triangle. Not only a triangle, excuse me, a right triangle. So this will not work on other triangles. It has to be a right triangle, okay? Very important to remember that. All right, so we got a squared, that's a crazy A, plus b squared equals c squared. Notice this time they gave me c, so I'm not finding the hypothenuse this time. I'm solving for b is what I'm solving for. All right, so let's plug the values in. Here we have 8 squared plus b squared equals 12 squared. This equals 64 plus b squared equals 144. And then simply, this is just a two-step equation. So we're going to subtract 64 from both sides. And that gives me b squared equal to, what does that equal? 80, there you go. It equals 80. Last step, always the last step is to undo this part. So you take the square root of both sides. This side, if I take the square root of b squared, it just becomes b. And the other side, 80 is not a perfect square. So you have to listen to your teacher, see what they want, because you can leave this as a final answer. And I believe if you take the square root of it, it should equal actually close to 9, somewhere around 8.9. So if they want you to approximate, this wouldn't be equal, right? This would be approximately. So at that point, you have to listen to your teacher whether they want that answer or they want just to leave it in this format. Okay, so this would be the second one here, would be considered the exact answer. This is an approximate answer. All right, either way, I hope you know how to use the Pythagorean theorem now. Right, pretty simple, straightforward, but only use it with right triangles. All right, thank you guys so much for watching, and I'll see you next time on Math Quiz. Goodbye.